Hi, my name is Michael Okuri. I'm a double major of management and marketing at UAA. And for my emerging technology project for this MIS class, I chose neuromorphic technology. I chose this topic because I sort of thought I understood what it was, but it wasn't until I started researching it more that I realized that I just had barely even a basic concept of what this technology encompasses. It's not so much one field of science as it is really a collection of multiple fields of science, all working together towards a common goal. You have neurobiologists, you have database designers, you have electrical engineers, all working together towards that goal. But the first question that needs to be answered, and probably the first one on many of your heads, is what exactly is neuromorphic technology? The word neuromorphic actually comes from the Greek words for to change into a brain, or to make into a brain, or to create a brain. And I think that's honestly the easiest way to explain what this technology is. The overall goal is to create a computer with the high functioning, low power usage of the human brain. Neuromorphic engineers also hope to accomplish this using both digital and analog components. And you'll see why neither one nor the other truly works towards accomplishing this goal of creating a synthetic brain when we go over the history here in a second. All you really need to know is that neuromorphic technology seeks to create a synthetic brain. So just to give you a brief rundown on the history, neuromorphic technology was developed by the American scientist and engineer Carver Mead in the late 1980s. The dominant technology at the time was analog technology. His concept was to create very large scale integration systems using analog components. And the reason they're called very large scale is because they were very large scale. They were basically massive analog computers that were attempting to capture the processing power of the human brain. And knowing what we know now, we sort of understand that that wasn't really possible. So throughout the 90s, we had the digital revolution, the 90s and the early 2000s. And this convinced neuromorphic engineers that it was probably possible to create a synthetic brain or to meld mind with machine using digital components. And so microprocessors, they were basically trying to create faster, more powerful microprocessors, ever faster, ever more powerful, hopefully leading to the processing power of the human brain. However, according to Moore's law, these processors are going to get smaller and smaller and smaller and more powerful and more powerful and more powerful to the point where digital technology, it is theorized, will literally not have the actual processing power to actually emulate the human brain. And so what most modern neuromorphic engineers attempt to do now is to create a hybrid digital analog model connecting digital processors with analog circuits. What this will do will give them the speed and power of digital technology, and it'll combine it with the flexibility and the low power intake requirements of analog technology. And coincidentally, when you create a device that is digital processors connected by analog circuits, it physically more closely emulates the human brain. So that's kind of a fun sign to think that maybe we're on the right track now. Some of the advantages of this technology: why exactly would you want to create a human-like computer? We'll get smarter devices. So devices that are faster require less power. But on top of that, devices that are capable of learning what the user is using them for. So they can create a more streamlined, tailored experience for the user without even having to be told to do so. You'll have, and this is one of the business applications of it, you'll have a machine mind performing big data analytics and other complex tasks. So in the past, where the capability of the human mind was a limit as to how much raw data somebody could process or analyze, you'll now have a computer that is able to think like a human managing this data. So they'll be able to respond to anomalies and problems faster. This gives it several applications in the emergency room and on the battlefield. So if you can think of a smart EKG machine, EKG monitor, one that can detect an anomaly with a patient's vitals more quickly and get that information to the necessary people more quickly, that'll save some lives. And applications on the battlefield, such as smart weapons, the easiest example of which is something that's currently in development, is smart drones. So drones that are capable of finding the target, identifying the target, and eliminating the target on its own processing power with no human input, with minimal human input. And it is if you consider AI, an advantage, it is a critical step towards artificial intelligence. You cannot have a robot that thinks like a human unless its circuitry is capable of withstanding the human mind, if that makes sense. We need to create the base of the human mind before we can actually put the human mind in that base. Some of the disadvantages, and I've broken them down into practical concerns, ethical concerns, and privacy concerns and security concerns. Some of the practical concerns, throughout humanity, we've seen machines take the place of what was traditionally a human's job. So, throughout the 1900s, we had this massive industrial revolution. In the early 1900s, we had the Industrial Revolution, and human beings were being replaced on the factory line by machines capable of doing the same thing. Currently, we have even more complex machines doing the same job as that humans used to do, on the production line. And you go to McDonald's nowadays, and they have the touchscreen ordering pads. The humans' jobs are being slowly stripped away by machines. And the disadvantage to this type of technology, at least in the practical sense, would be that even more human beings' jobs could be rendered obsolete by these machines. So, up till now, we've only had to be concerned about what is traditionally a blue-collar job, people working with their hands, robots taking over those jobs. Now we might also have to worry about what was traditionally considered a white-collar job being rendered obsolete. I have listed here database design, statistical analysis, accounting. These neuromorphic devices would be able to do all that. And so, soon accountants may have to be worried about their job being taken over by a machine just as much as an assembly line worker. Ethical concerns, this is obviously diving into the metaphysical. How much power should we give to our machines? This kind of goes along with the practical concern a bit. Should we really be giving the machines this much power? Aren't we supposed to be the ones in control of our machines? Why are we giving our machines the power to possibly, control us to where we can only we can only do what is now considered limited, or what is considered possible due to the limitation of our machines, if that makes sense. So we can't do this because our machines can't do this. And the more power we give to our machines, the more we sort of rely on that sort of thought. Privacy concerns. So companies like Google, Facebook, they operate on data mining. Most of us are aware of this. Some of us still think they just make all their money from ad revenue. I mean, and that's true in a certain sense. However, these companies, and you'd be surprised to learn how much these companies have on you, how much data they have about information they have about you. They know your age. If you've ever used Google, if you have a Google account of any sort, or you've been on YouTube, or you've used Facebook, which I'm assuming most of you do, you've already surrendered your name, your age, your gender. You've also surrendered your interests according to the pages you followed and the Google searches you've made. These companies have a massive amount of data collected on you. The only thing that's stopping them from compiling more data on you is the limitations of their software, their machines, their computers. And so if they had machines that were capable of processing an even greater amount of raw data, it's only natural to assume that they would attempt to, gather more of your data. So what I have written here is, are we willing to surrender even more data to data mining corporations just for a more streamlined experience on our smartphones and when we're surfing the web? Security concerns, this one's kind of obvious. Physical safety, should we be really making smart weapons? Should we be making drones that can identify a target and take it out? Because if they get it wrong, then should we really be making robots that can target humans? All right, some of the new business applications, design of new products, inclusion of cutting-edge tech and features, and new products being brought to market. So if you guys can think back to, Apple is usually the one that's guilty of this, guilty in a good way. So if you guys can think of back when Siri first came out, everybody was buying iPhones because of Siri. Everybody thought it was so cool that they could talk to their phones. And Siri is actually a neuromorphic tech. It's vocal recognition, which is an inherently human trait, the ability to understand language, which we've now given to our machines. And but it's tech like this that makes these new products, more attractive to the consumer, and therefore it's a great business. It's a great application for business. Differentiating your device and making it more appealing to the consumer. Some of the other current neuromorphic technologies, we talked about vocal recognition, the facial recognition on your phone. You can now unlock your iPhone with your face. Predictive text, the phone starts to learn what you generally type and tries to make it easier for you, tries to give you a more streamlined typing experience, texting experience. Google is currently working on what they're calling learning to learn programming. And that's sort of what we're talking about here with the predictive text, is that, and what we've spoken about earlier too, where the phone is capable of, or any other smart device, is capable of learning how you're using it and adapting itself to create a more streamlined, tailored experience for you. So basically all of these are just great, new features that we can start to look at in our smart devices that are going to be coming out soon, that are going to allow businesses to differentiate their products and bring them to market a little more easily. Some of the, as I said, I'm a management marketing double major. I see more, not that there aren't any applications for management, but I've seen more marketing applications for this technology than anything else, including what we've already spoken about. This is all stuff you need for marketing. Database management, data analysis, especially for big data. We're running out of how much raw data we can process as human beings with our current classical computers. More efficient sorting of information, better algorithms. Software that can learn from past anomalies and problem solve autonomously, and new products and brand differentiation. These are already things we've discussed thus far. However, to give you a better sense of how that helps us in a marketing sense, you now can collect more data on your target market. You can sort through that data faster. You can analyze it, see what the market wants. This is all being done by a computer. See what the market demands or wants in the next generation of, let's just say, your smartphone that you're developing. You now know what your target market wants from their smartphone. You can now develop that smartphone using new neuromorphic technologies such as facial recognition, vocal recognition, predictive text, that will allow you to differentiate your product, to set your brand ahead. So, when Apple first came out with Siri, that separated Apple from the rest of the pack. Nobody else really had what Apple had there. And so Apple was able to capitalize. Just using that one technology, they were able to differentiate their brand. To this day, we still sort of consider Apple the leading innovator on what's happening with smartphones. Just new technologies like that will set your brand apart, always make your brand look like the cutting edge brand. So not only will you be able to analyze the market and bring your products to the market with more efficiency, you'll also be able to differentiate your brand overall using this neuromorphic technology. In conclusion, I think I've already gone over time. In conclusion, neuromorphic technology is an exciting emerging tech that has the potential to drastically change our lives, hopefully for the better, but not without concerns. So sort of what I was bringing up with the disadvantages slide, these practical concerns such as, the machines are going to take our jobs. I would argue that we've never had a technological revolution where people have not had these same concerns. And I would argue that we've always made it through those revolutions, smarter as a society, more efficient as a society, and in my opinion, happier as a society. So if we can learn to work hand in hand with these human-like machines, I think it would be for the benefit of society as a whole, rather than refusing to progress because we're afraid of what may come. So thank you for watching this. And I hope you learned something about neuromorphic technology. If you have any questions, feel free to email me. It should be there on Blackboard. Or, just find me on campus. Thanks again, and I'll see you soon.